Okay, so guys, welcome to my channel. Thank you for watching the videos. Yeah, so continue watching. So to begin with, this you can only solve these questions using or we call this application of. So we call this kind of integration techniques as application of partial fractions. So partial fractions, it's the same as you have a fraction, then you want it to be so in short it's the application of, let me just say, partial fractions decompositions. So remember from our grade 12, so decomposition, we know decompose is same as dissociation or becoming small. Yeah, dissociating, like it's one big giant body mass that now you need to decompose it, becomes smaller body masses. Okay, so how do we do this? So briefly I'll talk about how you decompose a fraction. In grade 12, I remember there was something we were doing, like for example, you have 2 over x plus 3 plus 2 plus maybe 3 over x minus 2. Then they tell you to simplify this equation or express this equation as a single fraction, where you had to find a common denominator here, x plus 2, then x minus 2. Then you say this into this and this will cancel. You have 2 x minus 2 plus 3, then this into this, you have this, so it will be x plus 2. Okay, so meaning you have this multiplied by that, it will be 2x minus 2 multiplied by negative 2 to be 4 plus 3x and then plus 6 over x plus 2 x minus 2. Okay, so you further simplify this by grouping right terms, so you say 2x plus 3x minus 4 plus 6. Okay, so plus 6 over x plus 2 x minus 2. So this was this, it will be 5x negative 4, that will be plus 2 over x plus 2 x minus 2. So we learned this at our grade 12, but now we want the reverse. They give you this one, how do you get to these two? They'll give you this one, and we'll take it back to being like this. That's the more essence now. This we learned how to join them. Now we need to learn the reverse, how to break them. Okay, how do we break them? So I'll just draw some rules, which some common functions or rules which you guys have to be familiar with before we go into deep calculations. Okay, so so to begin with, let's say you have a fraction. So you have a function f, this is a numerator f of x. This function is divided by linear functions x plus b, x minus c. So by linear I mean x doesn't have a power, it has a power of 1. So this is same as a over x plus b plus b over x minus c. Okay, so we just get this over a. The power is 1 here, so a is a constant. these are linear equations, let me say. So this is linear because x has a power, the highest power of x is 1, so these are linear. So linear, they'll have just a constant. So let's say you also have another standard form. Let's say we have x plus a, but this time to the raised to power 3. So this is linear as well, inside this linear but repeating. So you have a over x plus a, then b over x plus a. So powers now are increasing, then plus c over x plus a to the power 3. So the highest power is 3, so it's increasing. Here power 1, power 2, power 3. If it was power 4, we would have written plus the same function to the power 4. So let's say you also have another standard form. Let's say this time you have a quadratic in the linear function. So this one we just don't write a, because this one, the coefficient for this function here, it will have x, so we write ax plus b over ax squared plus b bx plus c plus this one is linear, so we'll just say c over x plus d. So this is the standard form. We have written ax here because x is no longer linear. The coefficient of a will no longer be, because this function is no longer linear, and no wonder there is x here. So don't be surprised, we haven't started solving, so don't be surprised what is a, what is b. No, don't worry, you understand them as we continue solving. Okay, so let's start really with we start with question 1 so that you guys see what I'm talking about. Okay, so part 1, we're told to integrate. So we are told to integrate x plus 3 over x plus 2. So if you see this, it's very difficult to integrate. You see there are too many variables. So what do you use? That's where now where partial fraction decomposition comes in. So we just get this function here. So I'll write it x plus 3 over x plus 2. So we'll decompose it. So this one is a linear function. It's a power 1. So there are two functions, x and x plus 2. So we'll say a over the first function, which is x, plus b over the next function, which is x plus 2. So now the job here is to calculate the value of a and b. So I was just rewriting this equation. So we only focused on the numerator, the denominator, sorry, the denominator. So the denominator has two equations, x and x plus 2. So you have a over x, then the other one b over x plus 2. So here we will multiply both sides. So when I say both sides, I mean there is this part of the equation and this part of the equation. We multiply both sides, right and left, by x plus 2. So I will write, we have x plus 3 over x plus 2 equal to a over x plus b over x plus 2. So I'm multiplying everything by the denominator here, which is x plus 2. So if you see this side, you have you have x plus 3 over x plus 2. So if you multiply this by x plus 2, this and this will cancel, this and this will cancel. We want to remain with this one. This is this side. And also this a over x you multiply by this. So a over x multiplied by x plus 2. So this and this will cancel. So it will be just a multiplied by a plus 2. Then for b is over 2a, x plus 2. So we multiply it by x plus 2. So this and this will cancel. It will just be bx. So hope you guys have understood how we are multiplying. This is multiplied by this. This is multiplied by this. This is also multiplied by this. So meaning if you on your left, it will be just x plus 3 equal to a will be what? X plus 2 plus b, which will be just bx. So for those who are sharp, easy. It's very easy. What you should do is you just get the numerator here, numerator. Then these which are here, a is being multiplied by the denominator of b, and b is being multiplied by the denominator of a. That's all. That's what we have been doing, what we have done here. So don't be confused. Okay, this is the numerator of b, and this is the numerator of a. Okay, so now we have two. If you remember, the denominator has two equations. It is x and x plus 2. So we are trying to find a and b. So we can't solve minus solving these two equations. So we have x plus 2 and x. So we say x equals to 0. When we say x equals to 0, you set x equals to 0. Meaning everywhere where there is x, it will be 0. So meaning here when you put the 0, this will go away. So you want to remain with a. Here we put 0, 0 plus 2, it will be 2a. Then here it will be 0. So meaning 0 plus 3. Same applies. You take this one, x plus 2, you set it equals to 0. It will be x equals to 0 minus 2. So x equals to negative 2. So this one, where is it coming from? A. X plus 2. So when we bring in negative 2, we know this one will be 0. So we just substitute here and here, and so for b. Okay, so let's say when x is equals to 0. So if you have understood, when x is equals to 0, b has x only. So it will be 0b. Then you substitute now. So x here you substitute 0 plus 3 equals to a 0 plus 2. If you want, you can write b where there is x is 0. So this is equals to 0. Okay. So this would be 3 equal to 2a. 0 plus 2 is 2. So you divide by 2, divide by 2. Okay, so this and this will cancel out. So you have a equal to 3 over 2, which is just the same as 1.5. Okay, that is a. Then the next part, when x is equals to negative 2. So where is this coming from? You are getting these equations. This one, x plus 2, you set it equals to 0. Then so for x is equals to negative 2. So we know, now we substitute negative 2 in this original equation here. So you have negative 2 plus 3. So here we are putting negative 2 equal to a. Where there is x, we put negative 2. Negative 2 plus 2 plus b negative 2. So here it will be just 1. equal to, this is 0, negative 2, positive 2, 0, which is equals to negative 2b, and you solve for 2b, which is negative 2, negative 2. So b is equals to negative half, which is just the same as negative 0.5. Okay, so now since we know what the value of a and b is, so we write the value of a and b here. So we'll say this equation was x, let me see it again, x plus 3, okay, x plus 3 over x plus 2 is equals to a, which is 1.5 over x, plus b, which is negative 0.5 over x plus 2. So now, meaning this equation now, we don't have any use of it because this is the same as this equation here. So meaning, integrating this equation is the same as integrating individually these equations, because integrating these, so here to be minus negative multiplied by positive minus 0.5 over x plus 2 dx. So this is more simpler to integrate than this one. So this is the same as in, so we take out the constants to be 1 over x dx minus 0.5 1 over x plus 2 dx. And we know the identity. You know the integrating a linear function is x is the power of 1. It's just ln of this. If you have a linear function, 1 over linear function is just ln x. So this is 1.5. This will be integrating, this is ln x. Very simple. Minus 0.5. This will also be ln x plus 2. So we know this doesn't have a limit, so we'll put plus c. So you know 1.5 is 3 over 2 in x minus half. 0.5 is same as half. So even reaching here, you finish your question, but I just like simplifying it a little bit further so I can take out the half. And then here we remain with 3 ln x minus half is outside, ln x plus 2, like this, plus c. Okay, I like it this way. Okay, so we have x plus 3 over x plus 2 dx. So we are doing all this so that we have simple equations to integrate. So the tricky part of this is knowing how to decompose a fraction. So the whole part is decomposing a fraction. When you just decompose the fraction correctly, you've solved the question. So let's see how to answer part 2. So part 2 is a little bit lengthy. So part 2, we have 3x plus 2 over x plus 3x squared minus 2x, so dx. So you guys need to be sharp. You know that x is common here. X can go here, x can go here, x can. So you can factor out x first of all before you even solve. Before we start even integrating, so you know x outside, you take it outside, meaning here to be x squared plus x minus 2. So you are factorizing. You need to be good at factorizing. Okay, so now at least it looks good. Let's now try to factorize this one as well, because in this form it will be challenging to solve. So we get this, which is here, we factorize this one here. So we have x squared plus x minus 2. Let's factorize this. So we know this is in a standard plus c. So we have a coefficient of x squared is a, coefficient of x is b, then we have c. So like this, for you remember grade 12 work, you find the product is a multiplied by what? C. Then you find the sum, which is b. So this is a, like writing it like this. Then you find factors. So a, what is the coefficient of x? 1 multiplied by c is this one. So you get with a sign. If there was plus here, you would have gotten plus positive 2, so negative 2. So negative 1 multiplied by negative 2, it will be negative 2. B is what? B is a coefficient of x. This is positive 1, so we just write 1. Then factors, we are looking for numbers, two numbers. When you multiply them, they give you negative 2. When you add them or subtract them, they give you 1. So you guys, by now you have to know how to find factors. So it's 2 and negative 1. So if you say 2 multiplied by negative 1, it will give you positive, what? Oh, multiplying, sorry. So I'm multiplying, meaning it's a negative, okay? So this is negative 2. And then if you say 2 plus negative 1, this is same as 2. This negative times positive minus 1, it should be 1. So you have this same as the sum here, you have this same as the product here. Okay, so this is not part of the question, you guys should just know. Okay, so you have x squared plus x minus 2. So we'll substitute where there is b, we put these values. So we can say x squared. So we are removing this one. This is b. So we are removing this one. We'll put 2 plus 2x minus x. So this is 1x, but we can't write 1x. This is 2, which is here. And then minus 2. Okay. So when you reach here, you remember, when you get work, you group these. So what is common here is x. Here to be x. Here what will be remaining to be 2. Okay. Then here we take out negative 1. Yeah. Negative 1. So negative 1 multiplied by x. So x, negative x divided by negative 1, it will be just x. And then here it will be positive 2. So what is outside, group them. You have x minus 1. Then x plus 2. So when you reach here, you need to make sure what is inside is balancing. Okay, so this is your equations. So now we'll substitute here, we'll write those two equations. So we'll say is it x, 3x plus 2. Okay, so 3x plus 2 over x. Now we'll write this one in place of the quadratic equation minus 1 and x plus 2 dx. Now we have factorized completely. This is factorizing completely. By now you don't have to have issues with factorizing, guys. Okay, so this equation now we need to decompose it. Decompose it so that it becomes easier to solve. So we'll write 3x plus 2. We need to decompose this fraction. So part of the problem is to identify how many linear functions do you have. You have 1, 2, 3. So you have 3 constants: a over x plus b over x minus 1 plus c over x plus 2. So all these are linear. No wonder x, these coefficients, they don't have x or variable x on the numerator because they are linear. Power of x is what? 1. So from example A, from example 1, I've told you, you are multiplying both sides of the equation by this equation, by this denominator here. So if you multiply this denominator by on both sides, here you just remain with 3x. So I've showed you guys, yeah, so here you remain with 3x. Then a over x, x and x, they will cancel, meaning you remain with this and this. So a, you have x minus 1, x plus 2. It won't have a x because x and x will cancel, plus b. B, what's a denominator of b? X plus 1. So x plus 1 will go out. So you have x plus 2. Simple. Plus c. C has a denominator x plus 2. So x plus 2 will cancel. You have x multiplied by x plus minus 1. So you have x minus 1. So this is very simple. You're just removing this from this denominator. So this one is x minus. So you can swap whether you want. You can put b, you can write x plus 2, but here that's where it will just change. It doesn't matter which one is a, which one is b. Yeah. So now, if you see, you have these equations, 3 of them. You have x minus 1. You also have x plus 2. So now we need to find for value for a, b, c. So I've showed you guys the tricky part. So I said here you equate this equation equals to x, b equals to 0, this equation equals to 0, this equation equals to 0. So the first one, x equals to 0. We have solved already because x is not attached to anything. And this one again, x minus 1 equals to 0. So we solve for x equals to 0 plus 1. So x equals to 1. Okay? This one, x plus 2 equals to 0. So which is x equals to 0 minus 2. So x equals to negative 2. Okay, x equals to negative 2. So now, here is a shortcut, guys. You don't have to waste time because you have a lot of questions to solve. You can't waste much time on the same question. So let's see now. We have x. So let's see the constants which have x. So b has x alone. C also has x alone. You've seen a doesn't have x alone. You see? So when we say x equals to 0, this one will go to 0 because this will be 0. 0 multiplied by everything is 0. C will also be 0 because when we put 0 here, this will be 0. So we only remain with this part and this part. Then when we come to this one, x minus 1. So you check here, which one has x minus 1? So when we substitute x equals to 1, this will be 0, this will be 0. So we only remain with the b part. Then x plus 2. X plus 2, which equations have x plus 2? So here has x plus 2, this will be 0. X plus 2, this will also be 0, we only remain with c. So what I mean is, so we write when x is equals to 0. So when x equals to 0, which ones have x alone? This and this. That one won't write because it will be 0. So you substitute now, where there is x, you put 0. 3 multiplied by 0 plus 2 equal to a. Where there is x, you put 0 minus 1, 0 plus 2. These others won't write because there will be zeros. So 3 multiplied by 0, 0 plus 2 to be 2 equal to, so negative 1. This is 2. This is just negative 2a. Okay, so we find a, divide by negative 2, divide by negative 2. So a equals to negative 1. Hope you guys are following. So Now when we say when x is equals to 1, this is this one now. So you check here, which one has x minus 1? This one. So A, we won't write A. C also has x minus 1, we won't write C, so we're only remaining with B. So we substitute now 3, where there is x we put 1, we have solved here. Okay, plus 2. So in case you are lost, don't hesitate to reach out to B. Then here there is x is 1, 1 plus 2. Okay, so 3 multiplied by 1, it will be 3, 3 plus 2, 5, equal to this plus this 3, 3 multiplied by 1, which is 3, so it will be 3 over 3 over 3. So B equal to 5 over 3. Okay, so now we are remaining with one part, this one, when x plus 2. So everything which has x plus 2, this will go to 0, this will go to 0, we remain with C. So we have, when x equals to, we have solved when x equals to negative 2. So we said when x equals to negative 2. So we have 3 multiplied by negative 2 plus 2. So this can put brackets equals to. So this has the plus 2, which is here. This is 0. This is 0. So C, we want to remain with the C. So C, x is negative 2. Then here is x minus 1. So negative 2 minus 1, negative 2 minus 1. Okay. So this is negative 6 plus 2 equal to C. This is negative 2. Negative 2, negative 1, this is negative 3. So negative 6 plus 2, which is negative 4, equal to, this is 6, negative, this is positive 6 over 6C. So divide by 6, divide by 6. So C equal to negative 2 over 3. 2 into 4, 2 into 6, 3. So now we know the values of A, B, C. So in this equation we had here, we substitute the values now for A, B, and C. So let's say A is what? Negative 1. So we had the equation 3x plus 2 over x minus 1, x plus 2 is same as negative 1 over x, plus B is what? B is 5 over 3, which is, say, 5 over 3, open bracket, 1 over. So make sure you write the proper coefficients the same way you had written them when solving. Then plus C is negative 2 over 3, 1 over x plus 2. Okay, so instead of integrating this equation, you can easily integrate these which are linear fractions. So we write now here, but integrating dx is same as integrating these individually, since we have separated the fractions. So negative can come out, so 1 over x dx, this is a constant, so it can come out, plus 5 over 3 integrating 1 over x minus 1 dx, negative and positive to be negative, this can also come out, integrating 1 over x plus 2 dx. Okay, So this one is pretty easy because this is linear, 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 and the 1 over linear function is ln that function. Simple. So this is same as negative 1 over x is ln x. That's an integral. Plus 5 over 3 1 over x minus 1 ln x minus 1 minus 2 over 3. This will be ln x plus 2. So we are adding plus c because we don't know the limits. So yeah, we add c because we don't know the limits. They didn't give the limits, so we add plus c plus a constant. So we can further simplify. If you see here, we can take out the 1 over 3. 1 over 3 is common. So negative ln. For some who are lazy, you can leave it here, but it's best if you take out the 1 over 3. 1 over 3. Then here you have 5. 5 ln. This is 5. 5 ln x minus 1 minus this will be 2 just this one 2 ln x plus 2, so plus c. Yeah, so this is your answer. So I'll just write it, integral of 3x plus 2 over x dx equals to so wherever you are integrating, if they didn't give you the limits, you add plus c. So I'll stop this video and create part 2 where I'll solve 3 and 4. Thank you for watching. Okay, so stay tuned.